Today we are going to discuss another type of class builder in Python called NamedTuple. NamedTuple, there are two types in Python. One is in collection module and another one is in typing module. We are going to discuss both of these. And in order to understand this NamedTuple in depth, let's take a problem statement where, or let's consider a situation where we want to create a class object which holds some or which holds collection of variables or collection of fields. And once we instantiate this class, we can assign some data and to create simple objects, and those object can be passed around in our Python code for some to do some operations in the code. So for this, we can simply let's say the initial idea could be to just go with this class definition where we are creating a class and we have an init constructor which takes two variable, and in the init constructor we are initializing two variables or two attributes called or instance attributes which we are going to assign when we receive the data. Now this is fine. You may think, okay, this will work, and this will work, but it has many disadvantages. For example, if I run this, as you can see here, I am creating the class and I'm instantiating this class with two simple data. One I'm assigning to the company attribute, another one I'm assigning to the price attribute. Now, if I try to print this object, so what I'm going to get is something like this. It says main stock object at some memory address. This is really not a nice way to represent this object, right? So it does not have a good representation written. So basically what I'm trying to say is we have to write our own dunder repr method to get a nice representation of the object. So that is one thing I have to do here, right? The second thing is equality operator. Like for example, if I want to compare two objects, for example, here I have let's say I add this S1 and S2, S1 and S2 object. So S1 is a stock instance, and S2 is also a stock instance. Both of them are initialized with the same data for both company and price. And if I try to compare these two by using the equality operator, for example, if I write like this, and if I run this code, what I'm going to get is false. So Python is right here because we are comparing the object IDs here, S1 with S2. Obviously, they are different objects, but they contain same data. So when we are dealing with this data builders or class builders, which we are designing to hold or which we are designing to hold some data in them or create objects which contain some data in them, we don't have any other functionalities other than just asking them to hold some data. So they're just like some kind of data classes, right? So here, when I'm trying to do comparison of those kind of objects, I want to compare the fields, not the object IDs. So for example, if I want to do something like that, if I that is my idea, then I have to implement this in the dunder equal method and return true if it is true or return false if it is not true. For example, here both company of object S1 and S2 are same and price of object S1 and S2 are same. So in that case, I want to compare these fields or the attributes, not the object IDs. So that is my goal here. So if I do that, then I get, for example, if I try to print this, then it's going to say true because it is same. As you can see here, it says true. So this is again it's something extra I have to add to this class. So we have to add repr method, we have to add dunder equal method, right? So this is all extra things, extra code I have to write. And another important thing here is if I use init constructor to like initialize the object or create an instance of this class, then as you can see here, I'm repeating these variables many times, right? It is too much verbose code. So this is a lot of disadvantage. What we are trying to do is we just want to create we just want to create or build simple data classes which hold some data for us, nothing else. So this is where Python allows us to do, or Python has these inbuilt classes like inbuilt functionalities like NamedTuple and data classes to achieve this, right? So basically, NamedTuple is a simple function which builds a subclass of tuple using the name of the class and the attributes we are going to provide. So we are going to see like how to create those. And like I said, Python offers new ways, or Python offers multiple ways to build these simple classes. They are just the collection of fields, and they don't have any other extra functionalities. So if you see my YouTube channel, I have a series dedicated for data classes, and data classes again are the same. They do the same thing as what NamedTuple does, but they are little like they have much more functionalities than NamedTuples. If you're interested, you can watch that series. And like I said, data classes are again are user-defined types, and they let you group together some data and store those data in the objects. So now we'll understand name tuple. There may be, for example, I mean, in this type of scenario, I would suggest you to use data classes. But for example, for some reason, if you are tied to use only name tuple due to some constraint, then you are free. You should understand these name tuples and how they work and so on. So let's just get rid of this code and understand how we can use name tuples. So like I said, there are two ways of for using name tuples, or two different types of name tuples in Python. One is this in collection module with name collection module. We can import it like this from collection import name tuple, and this name tuple is all lowercase. And the way we create a class is by calling that function and passing the function, the class name and attributes. So as you can see here, there are two attributes. I mean, but it is in a single string, but the attribute names are separated by a space here. So basically, what this function does, it takes the first one as the class name and the second attribute as it splits the second string, and it finds out how many attributes are and then adds them as the attributes of that class. Now we have, like, once we run this line, we are going to have this class. And if you want to, for example, let's say initialize this class, all we have to do is we just have to pass in. I mean, the instantiation is similar to like what we used to do before, but we'll see what are the advantages and disadvantages. Not really. Yeah, there are a few disadvantages, but we'll understand them and see what happens here. Like now, if I print this stock instance, as you can see, we have a nice representation. So we have the class name and we have all the attributes and their corresponding values. This is one way of initializing. There is an, I mean, this is only way. But like as you can see here, the code automatically took this company and price as the attributes. But what happens if I want to, let's say, provide multiple values, or let's say I want to provide a list to this list as, or the other way to put it is, what if I want to create an attribute which holds lists, right? You can also do that. Like here, the code doesn't care. So for example, here, if I try to create a class, initially it will not know what type of data it's going to hold, right? But you can pass in whatever type of data you want when you're creating the instance of this class. Like for example, here it says, okay, we have three attributes, but it does not know like which attribute is what type. When you are instantiating, you just provide, for example, to the last variable, I'm providing a list, and to the first two, I'm providing one is string and one is float, right? So this is about name tuple, and also one of the disadvantage we had using the classical class definition was by if you remember, we could not use the equality operator, because when we use the equality operator, it was just comparing the object IDs. But now with the name tuple, if I create if I create, let's say, two instances of this class, and if I try equality operator, if I try to compare S1 is equal to S2, it's not going to compare the object IDs anymore. It's going to compare the data or the attribute values it is holding. So it's going to compare company with company of S1 and S2, and price of S1 with price of S2. And if I run this, it's going to say true. For example, if I were to change, let's say, this to something else, it's going to say false, because it's not same. So this is another cool thing about name tuples. So like if you remember, previously we had three problems. So one is init constructor, which was a lot of code, so we got rid of that. Second is the wrapper method. So now without adding any render wrapper method, we have a very nice representation of the object. And in the previous idea, we had to create our own equality operator, So that is not needed anymore because it's the name tuple is going to take care of the equality operator, right? So these are the some of the advantages of name tuples. And again, as the name itself says, these objects we cannot like once we have it, we cannot change the attributes, or we cannot write the attributes. It's only read-only attributes because we don't. These are tuples, so these are subclass of this whatever we are seeing stock and object. This S1, they are all subclass of tuple. So that automatically means we cannot. These objects are immutable. So right. So that is about name tuple. Now let's go and understand the second version of name tuple, which is from the typing module. Let me just get rid of this code. So the way we import the second name tuple, which was introduced in Python 3.6, is like this. So it is added to it was added to typing module. So we can simply say from typing import name tuple, and the way we initialize. So the only difference between the name tuple from collection and the name tuple from typing is that in this name tuple, you can provide type hints to the attributes. So, so since it's in typing module, you can easily know that because typing module is mostly used for type hint functionality. So similarly, name tuple is also in the typing means it should have some kind of type hint, right? So so the way we create the class is there are multiple ways to create the classes. So using this name tuple. So one way is just you call the function and then send in the function name, sorry, the class name, and you can provide all the attributes with comma separation, and you should also mention the type hint of these attributes. Right? This is one way. The second way is again is also almost similar, but you can provide the type hints as a list of tuples, and each tuple will have the attribute name and its corresponding type hint. So just so you know, even if you provide wrong type hints here, it does not matter because Python will not actually at runtime check if this type hints are matching in your data or not. Like for example, here I'm saying company is string, but when I create the instance of instance of this class, then I can provide anything to this company attribute. It does not care. So that's what is in the typing model. I mean, usually when you're using type hints, Python really does not care about the type hints during runtime. It is just for the developers. Usefulness because when someone else is checking your code, or if you are when you're writing the code, it's very difficult to it's mostly for the readability of the code, not really for checking or validation of your data in Python, right? So coming back, so this, like I said, there is a second way of creating the class using name tuple. It's like this: you provide a list of tuples to the list of tuples in the attribute section, and the class name is a string. So that is how you create the that's how you create your the name tuple using the name tuple from typing module. Now again, all the representation and all the, like for example, if I print S1 here, it's going to show a good representation, and I can also print S1 is equal to S2 or not to check if the equality operation is taken care or not. Right? If I run this code, I get nice representation and also get true because these objects have same data. And another thing you want to so this is the second way of creating the second way of how you can use name tuples, or how you can create classes using name tuple. There is a third way also, which is like this. So the all you so this way is maybe this way may be familiar to you, because in the case of data classes also we create the user defined types like this. So for here I'm saying, okay, I'm it's using the class definition itself, but as you can see here, I'm using name tuple as the parent class. So I'm inheriting from name tuple. So, but does not mean that stock is a subclass of name tuple. This may be contradictory because usually we know that if you have something in the brackets when you're creating the class sentence or class here, this will be considered as a parent class, and all the attributes or all the functionalities of this name tuple class will be inherited to the stock class. But the way Python handles this is different. So they don't use like the classic way of creating classes to create this stock. Basically, they use meta classes, which uses something like dunder new and so on. So don't worry about that. We'll cover meta classes later. But just so you know, stock is not a subclass of named tuple, right? But stock is a subclass of tuple, right? So this is the third way of creating a name tuple using the name tuple from the typing module. Now, again, like I said, you can create the stock class using I mean, you can instantiate this class like this. This will work. And like I said, you cannot use or you cannot modify the attributes outside the instantiation of the class. So like here, if I try to change the company attribute of the stock instance, it's going to throw an error. Or you can't. Okay, let me just clear this, save this, and run. It should show attribute can set attribute error. So this is the third way of creating or name tuple objects. So now we'll understand another important feature of name tuple. Let me just add in this code. So here I'm creating a stock class or name tuple class, and I have three attributes here. One is company, price, and shares. So this looks like some kind of a class variable, but they are not. Let me explain why. So if you see this company attribute, we are adding type hint to it, or we are adding the annotation to it, and we have another attribute called price. We have type hint for it or annotation, and we also have a default value for it. And the third attribute, it's called shares. It does not have type hint, but it has the default value. Now, what happens is when we create this type of data or this type of class, so what's going to happen is these first two variables, company and price, since they have the type hint or the annotation, they will be considered as instance attributes. And the third one, shares, does not have type int, but has a default value, but that will be considered as the class variable, right? So in order to see this, so if you, for example, build this class, and then if you find out the dunder annotation, if you just print the dunder annotation, you can see that it's going to have only company and price in the dictionary of the annotations. And the third one, which is shares, is since it's considered as class attribute, it will not be added to this annotation group. So, so that is all about name tuples. Hope you guys enjoyed this tutorial. Thank you so much for listening. If you have any doubts, please feel free to write them in the comment section. I'll try to answer them. And see you guys in the next video.